we are going to look at the media equipment, the sound media. The origins of sound-based mass media, radio in particular, can be traced primarily to the invention and spread of the telegraph. The telegraph was invented in 1840s by Samuel Morse, who invented the systems of dots and dashes that could be transmitted across the telegraph cable using electric pulses. The cable ran across the ocean floor, making it the first nearly instant one-to-one communication technology. Messages were encoded and decoded from dots and dashes on either end of the cable. But telegraphs couldn't transmit the human voice or other messages aside from language translated into coded electrical pulses. Ships, for instance, they could not benefit from telegraph technology, so they need to think of a technology to solve this. Heinrich Hertz began to theorize about electromagnetic energy, which is measurable physical energy in the atmosphere that moves at light speed. His theories fascinated Guglielmo Marconi, who began capitalizing on Hertz and others' theories of electromagnetism to inform and further his own experiments. Marconi then showed little interest in expanding the technology to transmit actual sounds like speech or music. Sometime in the late 1800s and early 1900s, there was a rapid technological advancement, experiments, and public demonstrations of radio technology. A melon farmer, Nathan B. Stubblefield, and a professor, Reginald A. Fessenden, paved the way for radio as a mass medium when they broadcast speech and music over a wireless signal in the 1890s. But the problem was that the equipment was too large and too complicated. So, J. Ambrose Fleming and Lee De Forest paved the way for much more controlled and manageable receivers. Lee De Forest made improvements on reception, conduction, and amplification of the signals, making music and speech sent wirelessly. So, radio is an audio or sound form of media. For this lesson, we are going to learn about the basics of audio. Audio is a technical term referring to sound coming from a recording, transmission, or electronic device. Sound is a generic word and can be caused by any source. Sound is the most important element in a media. What is the difference between the two? Sound is a terminology used in the analog form. The digitized form of sound is called as audio. What is sound? Sound comprises the spoken words, voices, music, and even noise. It is a complex relationship involving a vibrating object, which is the sound source, a transmission medium, usually the air, a receiver, the ear, and a preceptor, which is our brain. When something vibrates, the air is moving back and forth. It creates a wave of pressure. These waves spread like ripple from pebble tossed into a steel pool. And when it reaches the eardrums, the change of pressure or vibration is experienced as sound. Sound is a physical phenomenon produced by the vibration of matter and transmitted as waves. Sound pressure levels are measured in decibels. A decibel measurement is actually the ratio between a chosen reference point on a logarithmic scale and the level that is usually experienced. Sound waves are known as waveforms. Sound is described in terms of two characteristics: frequency or pitch and amplitude or loudness. Frequency is a measure of how many vibrations occur in 1 second. This is measured in hertz and directly corresponds to the pitch of a sound. The more frequent vibration occurs, the higher the pitch of the sound. Optimally, people can hear from 20 Hz to 20,000 Hz. Sounds below 20 Hz are infrasonic. Sounds above 20 Hz are ultrasonic. Amplitude is the maximum displacement of a wave from an equilibrium position. The louder sound, the more energy it has. This means loud sounds have a large amplitude. Sound can make or break a multimedia production, whether it's an audio slideshow, a documentary, or an interactive narrative. Most multimedia stories rely on 4 kinds of audio. Interview clips. Interview clips are recordings of stories subject, typically recorded on location or over the phone. Interview sounds bite can help bring the characters in our stories to life. Voiceovers. Voiceovers or voice tracks include any scripted narration that's recorded, usually in a studio, to push a storyline forward. Natural sound. Natural sound are the sound effects that we record on location, discrete, specific elements that command the listener's attention when they occur. Ambient sound. Ambient sound are the background noises that create a sense of place. For example, the sounds that make the character of a city park very different from a dentist's office or a bank. You need to know your equipment, the microphone, the recorder you use to get good audio. This means knowing where and how to position microphones and where to monitor the volume on recorders. It also means knowing a few general things about how microphones capture sound according to their polar patterns, pickup types, and form factors. A microphone's polar patterns determine its directionality and the angle form which it picks up sound. Some microphones are highly directional, capturing sound from a relatively narrow angle. Others are omnidirectional, picking up sounds from everywhere. Cardioid microphones capture everything in front and block everything else. This front focus pattern will let you point the mic to a sound source and isolate it from unwanted ambient sound. For example,
so here is Cardioid, and I'm going to sing a 32-bar opera ballad. No way. And checking, testing. Check, test. I'm walking around to the back of the microphone now, and it should be a little bit quieter than it was in the front. Checking, testing. And now it should be a lot louder in the front.
Cardioid microphones ideal for live performances and other situations where noise reduction and feedback suppression are needed. When to use cardioid microphones? It records what you point it at and ignores just about everything else. On stage, when sound is coming from every corner of the stage, a cardioid mic is great for maintaining isolation and preventing feedback. Miking up a drum kit. It is possible to separate sound of an instrument close to other instruments with a few well-selected cardioid mics. In rooms with poor acoustics, put close miking with cardioid mics to minimize the effects of harsh room reflections. An omnidirectional polar pattern picks up sound in a 360 degree radius. It is equally sensitive to sound at all angles. Imagine its pattern as a perfect sphere in 3 directions. This makes omnidirectional microphones ideal for studio recordings, where the objective is a natural, open sound. For example,
and here we go. Checking, testing. And there shouldn't be much at all, if anything, of a change in volume or tonal characteristics, although this microphone will change slightly in tone as you walk around, even in Omni, but the volume should be staying essentially the same all the way through.
when to use omnidirectional microphones? When you capture the sound of a room, when recording drums and guitar, or capturing a wide sound source like orchestras, choirs, and grand pianos. Digital audio. Digital audio is created when a sound wave is converted into numbers, a process referred to as digitizing. It is possible to digitize sound from a microphone, a synthesizer, existing tape recordings, live radio and television broadcast, and CDs. The quality of these digital recordings depend upon how often the samples are taken. Audio will most likely be the primary delivery mechanism for your story's narrative, whether it's through sound bites or voice over track or some combination of the two. Without sound, most multimedia and video stories simply can't be understood. This is why it's important to add subtitles to any video content to focus what is important. It is imperative to start with good, clean sound for anyone who will be talking in the story. Voiceovers tend to be easier since they are usually created in controlled environments with ample time to set up in advance and the opportunity for multiple takes. The sound bites captured from interviews present more challenges. These tend to be recorded on location. That means less control over the recording environment and fewer, if any, chances for redos. This is where you should spend the most effort on getting the best possible audio, and that usually means preventing or minimizing bad sounds, otherwise known as noise.